All right. It must be 2 hours UTC because Astronomy Daily Live is now live. Hey, everybody. Nice to see you. Nice you could stop in. I'm going to pop out my chat here. Get that going. Going to come over here to my smartphone and load the actual stream so I can keep an eye on that. So hey, I hope everybody's doing good tonight. Oh, let me plug this in, just like that, so I don't have to hear myself. Yeah. So welcome everybody again to the circle of friends. We're going to talk astronomy for at least the next hour or so, and we do this every single day. There's always something to talk about in terms of astronomy. So never, ever, ever a dull moment or a time when there isn't anything to talk about. So hope everybody's doing good. Cheers. It is the hydrogen hydroxide again tonight. It's just it's just extremely calming and delicious. So cheers. All right. Well, cool. Hope everybody's doing good today. Everything's good here for the most part. Let's see. Yeah, don't really have anything exciting to report at all, so I'm gonna hang just for a little while. Um, Wait and see if anybody else comes in. So yeah, this is just a casual, fun, educational, hopefully. Um, Hopefully, the quality is relatively high as well. Always trying to get better and better every single day. Um, I get an hour of practice in uh, each day. So as a musician, I can appreciate that for sure. That's a nice solid amount of time to get some practice in and just get better and better and better and better. So yeah, hope everybody's doing good. So this live stream is for everyone. This is for people who are new to astronomy and don't know a thing at all. It's for the amateurs, it's for the advanced amateurs, and it's for the pros. Definitely want to get some pros in here to, you know, um, either talk about research that they are doing, or just have a debate or some kind of a conversation about something astronomical. That can always be extremely fun. If you ever want to be on the panel, right, you can um, get yourself on the panel down here. We can have a live conversation. Um, just send me an email at cosmiclettuce@gmail.com. And when the stream goes live, I will send you a link and you'll be able, I think, to get on as a panelist. I'm going to be working on the Discord channel probably this week to see if I can get some audio going there, because I know that Uncle Bill wanted to do that before, because I wanted to get him on to talk about Cal Sky. So my Discord channel is, there's a link down in the description right now, so you can get onto that. I've got 4 text channels and 1 voice channel, um, and these are nice because they can sort of be an ongoing conversation, just a place to drop uh, pieces of information, little pieces of news. Um, Earlier today, I noticed that, um, uh, let's see, was it in space? We're still having sort of an ongoing conversation about about SpaceX's launch of the Tesla and Spaceman, and you know, just talking about where it is and what the configuration is, and orbital elements, those kinds of things. So yeah, very very cool. So feel free to join in the Discord server as well, so we can have an ongoing conversation there. I'm gonna put my chat back up. Don't know if OMC Triple X is still here, but if you are, hey, thanks for coming in. Thanks for joining the circle. So yeah, this is for everyone, um, and yeah, we can do Q&A. We can talk about telescopes. We can talk about instrumentation, cameras, spectrometers, photometers, polarimeters, anything. We don't necessarily even have to stick to the optical astronomy, right? We can stick, uh, we can talk about the other aspects of the science, which mainly deals with just different wavelengths of light. So as I keep saying, the science of astronomy is sort of you know one of those things that's about everything, and it's about the very very small, the subatomic to the cosmological. So we talk about the extremely small and the extremely large. The other thing that astronomy does is it's able to make observations and collect data at many, many different wavelengths, from the highest energy light, which are like the gamma rays and the X rays, uh, all the way through um, the ultraviolet, and of course the visible, through the infrared, through the submillimeter, to uh, radio, and everything in between. So it's an all um, um, uh, all encompassing uh, discipline, and it's awesome. It's absolutely fantastic because we get to talk about everything. So pretty much, yeah, the sky is the limit, right? Cheers. But we can also talk about like astro-art, um, both visual art and audio art, or any other kind of art that maybe no one has thought of or seen or heard. So yeah, bring it on. I would definitely like to see some interesting things. In most of the professional papers that I read, most of them do have diagrams or um, charts or um, um, images, anything like that. And a lot of them are, pretty beautiful things to behold. So just looking at those things, it's like, wow, this is very, very cool. Very, very cool. We can talk about certain telescopes or certain projects, like astronomical projects that are going on, or either are happening now, or will be in the future. Uh, talk about building telescopes, making mirrors, um, all the gear. Uh, yeah, pretty much anything astronomical is what this show is all about. So I'm glad everybody is able to come in live. Those of you who are watching this in the future, hey, from the past, nice to see you. The past, for, at least from my perspective, is going pretty good. So I hope that the future is about the same. So yeah. So let's see. I had a friend today asking me more about stars, and the question was asked. It's like, okay, do I mean, uh, when you look at a star through a telescope, I mean, is that basically what you do? And uh, I gave a sort of a long answer, which I'm going to give now. Maybe not quite as long, but who knows? I've got a lot of time, and if not today, there is tomorrow, and the next day, and the next day, and the next day, probably. So my answer starts by saying, well, it sort of depends on where you're coming from first. If you are an amateur, then you usually aren't just looking for or at stars. Stars are completely um, um, unresolved, which means they are always going to be just single points of light. Hey, Uncle Bill, nice to have you here again. I hope that all is well, and I'm I'm probably one of 10 shows that you're watching at the moment. So glad you could chime in and come into the circle for a while. Um, just talking about observing stars. I had a question about that today, so I just wanted to expand on that a little bit more. So most amateurs aren't necessarily pulling out their telescope like that to look at stars because they are a point source. Even if you magnify it a lot, they're still going to be a point source. Um, and that's just because these stars are so far away. I mean, they are just insanely far away that uh, it's perspective, right? Further away something is, the smaller it seems to be, and that goes for all things, including stars. So even if you have a huge star, right? Betelgeuse, um, uh, through this kind of telescope, and most of the amateur um, scopes, it is going to be a single point source. So you're never going to be able to see, sunspots or any kind of detail at all. It's just going to look brighter, right? And it looks brighter because our eyes, right, are at the most maybe like a centimeter across or so. Fully dilated. They're that much, right? Well, this telescope uh, is what, 20 some centimeters. It's an 8-inch, so I'll convert that to, uh, yeah, so 20.32 centimeters. And of course, what we're interested in here is the area, right? So let's see. Let's just say that fully dilated, our eyes have a diameter, have an aperture of 1 centimeter. Okay, 1 centimeter. Uh, yeah. Hey, I saw that Jason was doing that, and looks interesting. I'm gonna have to watch that. I've I've sort of determined that as a programmer, it's really, really difficult to watch other programmers do their thing. It's uh, it's just, yeah, it seems really, really hard. It's not so hard to watch like astronomy shows and stuff, but for some reason, for some reason, I was watching Big J the other day on his programming show, and it was kind of just driving me bonkers. Um, so yeah, I'm gonna have to try that again. Anyway, let's just go with with a full diameter of 1 centimeter. That's probably a little bit big, but eh, it makes it easy. So the area of our pupil, then a fully dilated pupil, is pi, the value pi, times the radius squared. So the radius is just half of the diameter. Okay, so that's 0.5. And I'm going to square that. And then I'm going to multiply it by pi. And I get 0.785 square centimeters. So not even quite a square centimeter. So 0.785, I'm going to store that. I'm going to remember that. Now this guy here, this guy has a diameter of 20, what did I say, 20.35? 20.32 centimeters, okay? Which means a radius of 10.16 centimeters. I'm going to square that, and I'm going to multiply that by pi, and we get 324.29 square centimeters, which is, so if I divide that number by the aperture of my eye that I calculated before, we can get a ratio, right? So this telescope behind me here collects about 413 times as much light as my eye does. So we can see things, you know, that much more fainter, because these scopes, and in fact all telescopes, uh, um, you can sort of see them as light buckets, right? So the bigger the bucket, the more light it is going to be able to gather. So in this case, this bucket can see about 413 times as much as my eyes. So that's pretty good. That's pretty good. But it's all that's going to do in terms of seeing a star is it's just going to make it look brighter. That's all it's going to do. Fundamentally, that's all it's going to do. There are a few other things um, that large apertures do, but that's sort of the fundamental, most apparent thing. So most amateur astronomers aren't pointing their telescopes at stars because, frankly, they're just kind of boring, right? There are some cases though where you might want to look just at stars. Um, Most definitely, when you look at a star, you are going to be seeing some kind of color to it, and that's really, really nice. And what I recommend for that all the time, if you really want, you know, to bring out color and make it pop, is defocus the telescope a little bit, and you'll sort of spread that light out a little bit, and of course that'll spread out the color. So yeah, most amateurs are more interested in galaxies or star clusters or binary stars or globulars, you know, so-called non-stellar objects, NSOs. Now, professionals are definitely interested in observing stars, not just to take a picture of it, though. What they usually want to, what they're usually doing there is they're looking at the star with an instrument that's called a spectroscope. And a spectroscope just it takes the light from the star and it spreads it out into its constituent colors, and that allows them to make all kinds of measurements in terms of how hot the star is, what it's made of, how it's moving. And if you know those kinds of things, you might be able to get an idea of how large it is, how old it is, those kinds of things. Seeing maybe if it has a companion or two that you can't see visually, but you might be able to see it spectroscopically because uh, um, characteristics of the colors themselves are like, oh, okay, there there is more than one thing here. The one thing, though, that anybody can do, especially uh, with the brighter stars, um, is you can observe variable stars. Most of the stars in the sky are variable stars, in that they they get bright and then they get dim and then they get bright and they get dim over some kind of a time period that can last, from seconds, fractions of a second, up to thousands and thousands of years. Most stars are variable in some way. Our sun, luckily enough, isn't. It's it's a very, very, very stable star at this point. That could change pretty much any time. But what you know, when we look out um, at the stars and sort of compare similar stars to our sun, yeah, they're all sort of behaving the same way. They're pretty stable. So we can be pretty confident that our sun, isn't going to turn into some kind of a variable star. That would be pretty destructive to Earth. So yeah, we don't necessarily want that to happen. Now, stars um, um, seem to vary in brightness for at least a couple of reasons. The first reason is because they're actually changing size, right? So they're expanding and then they're contracting, and they're just doing this, right? Just expanding. Here, I'll do it with one hand. So expanding and contracting, just like that. And that's just because what at least the theory is that inside of these stars is some kind of a thermonuclear uh, um, engine in um, in the center of these stars, and the outward pressure of that um, engine is sort of pushing against all of the matter that wants to collapse in from gravity. And when when those two forces are balanced, you have a thing like our sun, where you don't have a lot of that variability, expanding and contracting, expanding and contracting. But in these stars, um, you don't have that kind of stability. So you see an expanding and a contracting, expanding and contracting. And because the apparent size of of the star, and actually not the apparent size, the actual size of the star is changing, um, what what we see is just a brighter star when it's big and a fainter star when it's small. So it goes bright, faint, bright, faint, bright, faint, just over and over and over again. So that's at least one of the kinds of variable stars. There's a bunch of different kinds of variable stars, and maybe at some point I'll have to find a list of all the different kinds of variable stars. So what I'm going to go over tonight is just a couple of different ones, mainly because I'm sort of um, leading you in a direction uh, to make some observations that you might enjoy. Sci-Hub. Yeah, I think I I thought that was gone, but if it's back, I'm gonna have to look for it too. I think freedom of publication is is awesome. So yeah, I'll have to check that out. Thanks for the heads up, Uncle Bill. I will check that out again. They're awesome. They're very awesome. Um, so another kind of variable star is what is called um, an eclipsing binary star. Cheers. And this is when you have a binary star system where it just so happens that the orbit of the secondary star um, uh, is so aligned that from our perspective, it seems to pass in front of the primary star. And I think, did I pull up? I'm going to go to screen share here and see if I pulled that up. Did I? Let's see. Did I? Let's go up to the top here. Scanning very quickly. Here we go. Okay. So here's a primary star, and here's a secondary star that's going around. It's orbiting the primary star. And it's aligned with us such that you can see in the next frame that the secondary star has gone behind the primary star. And then as it swings around, it'll go in front of the primary star. And I'm going to hide this. And when you watch this happen, what you see is you can sort of see here when it's like in the A configuration here, when you can see both stars, then you're just going to be seeing that kind of thing. It's not going to be changing all that much. When you get this configuration like this, then you'll see that there's a little dip. So this is brightness over here, visual magnitude. And just as a reminder, right, the smaller the number over here, the brighter it is. So in this thing, it's bright here, and then it gets a little bit dark. But then, as you can see, when this secondary star passes in front of, eclipses the primary star, it gets really faint. It drops, let's see, this is, it's about 2.1 down to about 3.4. So, that's over one magnitude change. So that's pretty significant. And as you can see, the time between dips, which is just one orbit of this secondary guy here, they've got down to 2.86732 days. So down to the second, right? They have the timing of that down. And the cool thing about this particular star, which is called Algol, is that you can see this. It is a naked eye object, a naked eye star. It's up in the constellation of Perseus. Okay. And normally, you see how this, this eclipse, ooh, this eclipse doesn't last very long, right? It lasts, it just lasts a few hours, right? Just a few hours, couple hours. Um, so normally, when you look at Algol, it's going to look like that, right? Big and bright, everything else. The really, really cool thing is that right next door to it is another star that's usually a little fainter, right? But you've got these two stars. You've got Algol, which is the bright one, and then this guy here, which is Rho Persei. Okay? So when it isn't doing an eclipse, Algol is going to be brighter than Rho. Okay? But during an eclipse, as you can see, Algol gets about as bright as Rho. So if you go out and look at any particular time, you'll probably see this, right? Algol brighter than Rho. But if you know when to look, or if you're lucky, you may see it like this, where Algol is the same brightness as Rho. And that would mean that it is in some phase of the eclipse. Yep. Let's see. This is just showing a chart showing where it is in the sky. Cassiopeia is up here. Perseus is down here. Yeah, this is one of those things that you're just going to have to learn. Uh, as I said last night, you're taking a chart and being able to translate this um, um, up to the sky. That's some practice that you're going to have to do if you aren't used to those kinds of things. But you can even see this stuff in the city, right? These are pretty bright stars. So you should even be able to see it in the city. So I encourage you all to do that. Now, what I was doing and why I was running a little bit late um, coming into the live stream today was that I was getting over to Sky and I was trying to find a table that showed when Algol was going to be at a minimum, and I'm still looking, still looking. So let's see. This is the Sky and Telescope website, as you can see, and this is the section called This Week's Sky at a Glance. And I'm just going to do a search for the word Algol and see if it comes up here. Isn't. There are somewhere tables that tell us when Algol is going to be doing its thing. This is all, okay, so that's not it. If anybody in the chat can sort of maybe point me in a direction, otherwise I'm just going to I'm going to look around for a little while. I'm not going to belabor this too much. Observing projects, maybe. Lunar eclipse, white dwarfs. Another algol search. No algol there. Ah, frustrating. Frustrating not being prepared. I'm going to go all the way back here and see. See, this talks about it. Oh man, why did it take me all the way back there? See, this is 2012. This is 2017. That doesn't do me any good at all. Let's see if I can. If I go to rasc.ca, rasc.ca, see if I can pull up the observer's handbook or see what they've got here. Observing variable stars. Let's see what we've got here. Sorry to belabor this a little bit, but yeah, I wanted to show this off a little bit. Pulsating, rotating, eclipsing binaries. Okay, I think we're getting close. Here we go. There's a link to Algol. Don't know where this is going to take us. I'll look at Algol, Demon Star, Algol Paradox. There's some more light curves. You can see that the actual data, right, isn't quite as pretty as the plot that we just saw. Predicted minima for Algol 2000, but it's not a link. It's just not fair. Just not fair. Wouldn't do us any good anyway. That was for 2000. Hmm. Dang. I'm going to try to find a table because those kinds of things exist. I know, I know that Sky and Telescope, at least in the magazine, has it. It has it every single month. If I need to log in, yeah, I might have to log in, and I'm not prepared to do that tonight. Uh, huh. I was hoping that it would be either in this week's Sky at a Glance or maybe Observing News, but let's see. Let's do another search for Algol. Nope, nothing. Wow. Well, as you saw, though, the cool thing is that this happens about every 2.86 days. So it happens pretty often. You know, it'll happen what 10 times in a month. So you got lots of opportunities. And what I suggest, you know, if you don't want to look it up, to uh, uh, you know, to find out exactly when um, this particular star is going to drop in brightness, you can just be surprised, right? Every single night, go out and look. And sometimes it'll be bright and sometimes it won't. And yeah, it's very, very cool no matter what. Sci-Hub, maybe you need to log in. Site gives me more better features if you log in as linked. Okay, yeah. Well, I'm not too surprised at that you have to pay for that kind of information. I don't know. I don't know what kind of world are we getting ourselves into here. But you can actually do this for lots of stars, lots of stars. Algol is sort of the most obvious one, but as I said, most stars are variable. So you sort of just have to look that kind of stuff up. And a great resource for that I've used for many years uh, is Burnham's Celestial Handbook. And let's see, can I grab one? Let me grab one, and look, I'll put you back on this so you can see me exit just for a moment. I'm just going to grab one of these books. Hold on. So I've talked about um, this particular 3-volume set called Burnham's Celestial Handbook, and it's organized by constellation in um, alphabetical order. So this book is volume 1, and it goes from um, Andromeda, the constellation Andromeda, to the constellation of Cetus. So it talks about most of the stars and most of the non-stellar objects like galaxies and clusters. But what it also does at the beginning of every constellation section is it lists, let's see, yeah, wow. So here is, and I'm not going to be able to hold this up very well, but here's a list of all the binary stars or multiple stars that you can see in this constellation. There's one page, but it goes on to page 2 and page 3, page 2 and page 3, page 4, page 5, and yeah, basically 5 pages of multiple stars, binary stars. Then it has about a page and a half listing of all the variable stars that you can see in this constellation. And, you know, some of them vary a little bit and some of them vary a lot. For instance, a star named R Andromedae, has a variability period of 409 days, 409 days, and it varies from magnitude 5.3 to magnitude 15.1. So it goes from almost pretty much a visible star to invisible, and then back to visible on a period of 409 days. And they have information on, as I said, they've got them on a lot. Oh, I got to go back. A lot of variable stars in the constellation Andromeda. A lot of them. And so you can look at this list and say, oh, okay, I can observe that one and that one and that one and that one and that one. If you have a telescope, you can see even the fainter ones. So very cool, very cool. And you can do this in a visual way as long as you're able to compare the brightness of the star you're observing with some stars that uh, um, are in the same field of view and aren't changing. So as long as you're able to do that, you can do some visible variable star observing, and it's very, very cool. It's kind of neat to see things change. Um, uh, you know, maybe that is something that you're not quite used to seeing in terms of astronomy, or I'm looking at at the night sky. It just sort of seems to be the same over and over and over again. Well, I'm telling you, there is so much action. It's unreal. It's unreal. Everything is constantly changing, and uh, yeah, it's always in a state of flux, always. So that's what an amateur can do. You don't need, for a lot of these, you don't need a telescope. You don't need a pair of binoculars. You just need your eyes and a relatively dark sky. And sometimes it's nice to know when uh, these kinds of eclipses take place. So I'll try to find a table of when those things happen with the star Algol, because that kind of information is around somewhere. I just I'm not having any luck trying to rapidly find it, but yeah, I'll try to find it by tomorrow's show. Another cool thing about having a daily live stream is that it's like, well, I'm not able to find it today. Maybe I'll find it tomorrow, and that is good enough. That is good enough. Of course, professional astronomers are extremely interested um, in variable stars, and can use the same kind of instrumentation, like a spectroscope, uh, to really take a hard look at what's happening while the star is varying. And that's how they know, in the case of Algol, that it's actually a second star that is passing in front of the primary to eclipse it, because they can look at the spectrum of this and say, oh, well, it goes from this to this. And the only explanation for that uh, is that you're looking at a different star. So, yeah, very, very cool. So, yeah, that is just looking at stars. So, yeah, for the most part, if you're looking at stars through a telescope like that, it's not going to be incredibly interesting. Um, mainly, at least uh, um, when you're using this kind of scope, you're going to be going after galaxies and clusters and nebulae, those kinds of things instead. Yeah, stars uh, look pretty boring otherwise. They just look like bright, bright spots. Trying to think if there are other things that I thought of today. Um, I can definitely get into Burnham's a little bit more. Um, they pack a lot of information into these books, because not only do we get these lists, right? These huge lists of stars, variable stars, binary stars. They even list all the non-stellar objects, so all the galaxies, all the nebulae, how bright they are, where they are, brief description of them all, their sizes, all of that. Okay, now if that isn't enough, if that isn't enough, every single star, not every single star, but the main stars in the constellations all get these nice long write ups. Okay, so you can see the first one there is called Alpha, and in this case, it's the constellation Andromeda. So that is the brightest star in the constellation of Andromeda. It's usually how the naming convention goes, is that alpha is the brightest. You can see right below is beta, okay? But they provide um, um, all this info. Um, they give its name, its brightness, um, position. I'm just kind of scanning around here, seeing um, distance. So in this case, it's about 120 light years away. So yeah, relatively close. Not the closest one. I'm definitely not incredibly far away either. Uh, and then just lots and lots and lots of other information about the star. It can get into the history of the star, who observed it first. Um, in this case, it does appear to be a variable star with a period of 96.697 days. So that's kind of cool. Um, yeah, just on and on and on, right? So these guys, they go into a description of sort of the bright stars, the primary bright stars. So there's alpha, and there's beta, there's gamma, there's delta, there's zeta, lambda, um, omicron, pi, omega, and then some of the stars have numbers as well. So there's R, which I think we talked about already a little bit. It actually they show a light curve for our Andromedae down there at the bottom, and you can see that it goes from magnitude 7 down to like almost magnitude 15 over the course of I want to say about 200 days or so, something like that. But you can see that the light curve isn't a symmetrical thing either. So there's all kinds of interesting things going on there. Lots of dynamics. You have to read what they say about it to actually understand why the light curve is the way it is. You can also see in this light curve, you see that first peak. That first peak is higher than the second peak. And that first low point is a little bit higher, back it up a little bit higher than the second low point there too. So there's all kinds of interesting things going on. And you can discern a lot or infer a lot just by looking at the light curve. So if you have a way of measuring the brightness of these variable stars, you can make a similar plot, collect your own data, and start thinking about why is it that shape? What conditions there would would make that kind of a shape? Um, don't know. Don't know. I'm sure there are a few explanations in um, um, in the description here, and you can also do a search now on the internet and probably find out even more. So Uncle Bill says that the next one for folks at least being able to see it in the United States is going to be on the 19th of this month at 9:26 UT. And that's probably the minimum. So it'll start, an hour or so beforehand, and it'll end about an hour after that. So yeah, so yeah, my time, I'm just sort of doing a translation. So since I'm in southeastern Arizona, I'm on Mountain Standard Time. So I'm 7 hours behind Universal Time. So that minimum, uh, um, that minimum for me would take place at 2:26 in the morning on the 19th. So yeah, maybe that is something that I'll go out and look at. It happens all the time, so I'm those kinds of things I don't exactly sweat. But if you've never seen it, um, it's pretty cool. It's pretty cool. You know, as I said, um, when you usually look at it, it's much brighter than that other star next to it. But when it's in eclipse, it's about the same brightness. So that's pretty cool. It's neat to see things change up there, and it looks like Mr. Bill did an awesome thing and put a link in the Discord channel to calculate the minima of algol. So I'm going to go there right now and just sort of look at it. Yeah, it looks like I have to log in. So you're going to have to log in. Uh, no big deal. I don't. Well, I don't know. I don't know if that's a free one or not. So maybe there's another source out there too. But if you do have a login to Sky and Tell, you can certainly get over there, go over to my Discord channel, which I have a link in the description below, and go to the Astronomy channel, and you will see Uncle Bill's link to Sky and Telescope there. So thank you much, Uncle Bill. That's extremely awesome for you to do that. Unfortunately, I can't see it, so yeah. Sky and Telescope is like that. They usually want you to pay up a little bit for that kind of free information. So, but anyhow, Burnham's is like that. Now there are variable stars that don't really have any kind of discernible periodicity to them at all. I'm just looking at at the star called Z Andromedae, and um, it's a pretty strange variable star. It has outbursts, violent ones, where it gets extremely bright. But look at this light curve that they show in, in here. Look at that. Okay. Now, maybe there's a little bit of periodicity there. You know, the time between the peaks, you can sort of see that it, maybe, but there's all this other funny stuff going on. And at the end there, it gets fainter and just sort of stays there. So, you know, uh, the universe is a very dynamic place, and things are going on all the time. So, okay, okay, cool. All right, I I will get the free login at Sky and Tell, and so yeah, I'll be able to show that off here. Whether I do or not, that's probably not a big deal. Viewers of this show can certainly take a look at that too, but uh, um, maybe that's a nice thing to be able to show from time to time. Maybe we'll have every week or so, uh, I can sort of pop in over there and say, okay, when is alcohol going to be at its minimum, and I can sort of remind everybody about that, and I can talk about variable stars again, which are really really cool, very very cool, especially when you start getting into the light curves and seeing how complicated they are, and then on top of that, if you get into the spectroscopy um, and see uh, what is going on there in terms of you know uh, is sort of um, um, different chemicals and compounds and all that. Are they also varying varying over time? Um, yeah, it gets complicated really 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 fast, really fast. But Burnham's is pretty good about all these things. Here's another one, our X Andromedae that have these are all light curves of that one system, and yeah, it's just all over the place. So what's going on there? Piques curiosity, at least as far as I'm concerned. It's like what is happening, right? What's happening there? It's very very cool. The other thing that Burnham's gets into, if this isn't already enough, okay, if this isn't already enough, they also describe a bunch of the non-stellar objects. And of course, in the case of Andromeda, you have the Andromeda Galaxy, right? That's why, of course, it's called the Andromeda Galaxy, because it's a galaxy that appears to be in the constellation of Andromeda. Of course, and I hope you know this. If you don't, you're hearing it now. All the stars that you see in this photograph are in our galaxy, are in the Milky Way galaxy. They're foreground stars. So they are between us and the Andromeda galaxy, which is in the background, which is way, way, way back there. So because we're not really able to see any depth because these things are so far away, it looks like a 2D thing where all the stars seem to be, right around it. It's not the case at all. The Andromeda galaxy is way, way, way in back, and all the other stars that you see are foreground stars that are pretty close to us, pretty close. So, all right. Well, Burnham's is awesome, and these books are still available. You can still get them. I recommend going to like used bookstores and seeing if you can find them there. You'll you'll not only be able to get them, but you're probably able to get them at a really really good price. And for the information that's in these, it's absolutely fantastic resource. I got these as a kid, along with my charts, and I mean, um, as you can probably see, this one is actually probably the best one of the three in terms of being abused and used. I poured through these, just poured through them as a kid, for sure. Looked at a lot of the objects in them too, a lot of them. Great, great, great fun. All right, well, look, it's just past the hour, and I do respect your time and don't want to go too long unless there's some interesting conversation going on in the chats. I'm probably going to start winding down. Okay, cool, cool. Yeah, I'll definitely have to get a login over there and um, check that out. And yeah, maybe that can be a regular thing. I can find a few other variable stars like that too. Algol is sort of the most obvious one because it's visible and the difference in brightness can sort of be easily seen because you can compare the brightness to that nearby star. And just FYI, I think that nearby star, if you take your finger and um, 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 extend it out like that, right? And then look. I think I think the separation between Algol and that other star is about as wide as your finger, if I remember right. Maybe it's a little bit more. I haven't looked at that in a while. I'm going to have to look at that. It's cloudy today, so I'm not going to be able to look tonight. But yeah, I'll check that out and get back to you on that. But yeah, I think Algol, maybe the minima of Algol can be sort of a regular um, feature on this show because it's always very very cool to see things happening up in the sky. So all right, I think I am going to exit these waters for now. It's been a good hour talking about variable stars. Variable stars are very, very awesome. Lots of interesting things going on in those systems, whether it's a single star just sort of expanding and contracting. Those those kinds of things can be extremely complicated too. If you have, like in the case of Algol, and you have an eclipsing binary, those are very very cool too, especially when you start to think about you know um, um, what's happening and the fact that the secondary star is going all the way around the primary star in less than 3 days. Okay, I mean it takes our Earth what 365 days to go around our star. So the fact that it's going, you know, that time is so short, that means that the secondary star must be really, really, really close to the primary star. So it's only 3 days. That's insane. That's fast. That's really, really fast. All right, lots to think about. Glad you could be here. This is, just a fun circle of friends. Hopefully, pretty casual. It can get intense, from time to time, but hey, that's what astronomy is all about. Is getting into it, um, having a lot of fun, but I'm learning a lot, and being able to think about uh, things that maybe you've never thought about before, and uh, if you're completely confused, that's okay. That's a good place to be. You've joined the rest of us because it's a confusing place. It's a confusing place, and we're all curious. So we're trying to figure it out, and you have just stepped into that area of absolute confusion. Um, Anybody who says or thinks that we completely understand things, not not possible, not possible. So it's it's the process of science, and it goes on. It goes on and on and on. And when we get the answers to some questions, that leads to more questions, which leads to more answers, which leads to more questions, and on and on and on. It's awesome. It's awesome. It never ends. At least it hasn't ended yet. And that's just the way I like it. All right, I'm going to exit these waters. Um, Make sure to subscribe. Make sure you can turn on notifications if you're not able to figure out when this live stream is on for you. Otherwise, try to figure that out. Time is a concept that is important to astronomy. So I would recommend trying to figure that out on your own when 2 hours UTC is for your local area. Um, and make sure to hit the thumbs up. That helps get me, I think, into the recommended lists on YouTube a little bit more, and that's going to pull in a bigger crowd. And I'm looking for a bigger crowd for sure. It'd be nice to have a dozen or a couple of hundred in here. That would be extremely cool because then you know I'd well, yeah. I mean, it's not as if I'm going to sit back, but I think the conversation could be much richer than me just sort of blabbing along. I have no problem doing that when it comes to astronomy. So I'm more than happy to do that. But, with a bigger crowd, awesome. Very, very awesome. So make sure to do that. Make sure to share this, spread the word. I'm on every single day. uh, which means that you don't have to come by every day. If you want to and can, please do. You are extremely welcome to do so. Don't feel obligated, to come in every day. If you want to check in every week or every other day, whatever it is, come on in. You can leave some comments. Um, yeah, it's just very, very awesome, very fun. And all right, I think I'm going to get out of here for tonight and head back up to the ship. I will see you in a little less than 23 hours from now. All right, signing off. Peace out. And yeah, I will see you tomorrow. Okay, bye.